There's a block of stone in Bolivia that a modern machinist looked at and said he would not know how to make it. Not without a CNC machine. Not without diamond-tipped cutting heads and a computer controlling the tolerances. And the block he was describing was cut somewhere around 536 AD, at 12,800 feet above sea level, by people who, according to the accepted archaeological record, had copper tools, stone hammers, and rope. That machinist was not exaggerating, and he was not making a YouTube video. He was an engineer brought to the site to assess whether the precision he was seeing was real. It was real. The interior corners of the H-shaped blocks at Puma Punku, Bolivia, maintain 90-degree angles with deviations of less than 0.1 degrees. The flat faces deviate from true flat by less than 0.05 millimeters across spans of several feet. The grooves cut into the stone hold consistent depth to within 1/10 of a millimeter across their entire length. These are numbers from precision instruments, and they describe manufacturing tolerances, the kind of tolerances that appear in aerospace components and automotive engine parts, not in 1,500-year-old hand-cut stone. This is Puma Punku. And this is why, after 120 years of study, archaeology has still not been able to give a satisfying answer for how it was built. The site sits on a windswept plateau near the southern shore of Lake Titicaca, in what is now western Bolivia. It is part of the larger Tiwanaku archaeological zone, a UNESCO World Heritage Site, one of the most important pre-Columbian locations in South America. The Tiwanaku civilization was real, significant, and impressive by any standard. At their peak, roughly 500 to 900 AD, they controlled territory stretching across the Bolivian Altiplano into parts of modern Peru, Chile, and Argentina. Their capital city may have held 40,000 people. They built sophisticated raised field agriculture that allowed farming at elevations, where crops by rights should not grow. They created monumental stone statues that still stand today. The Bennett monolith alone stands over 24 feet tall. Nobody disputes the Tiwanaku. They were a serious civilization. What people dispute is whether the Tiwanaku built Puma Punku. Because the main Tiwanaku complex, located about a quarter of a mile from Puma Punku, contains impressive but comprehensible architecture. Stone walls, terraces, temples, construction that is clearly sophisticated but fits within the expected capabilities of a civilization working at this level and time period. Puma Punku does not fit. It belongs to a different category. And the measurements now confirm that difference in numbers that are hard to argue with. The material is the first problem. The H-shaped blocks, the most famous and most precisely cut pieces at the site, are made of andesite, a volcanic rock that rates 6 to 7 on the Mohs hardness scale. For comparison, copper rates approximately 3. Steel files rate 6.5. The standard archaeological explanation is that the Tiwanaku used diorite hammerstones to pound away at the andesite, a technique that is real and documented elsewhere in the ancient world. The unfinished obelisk at Aswan in Egypt shows exactly what this process looks like. Rough, irregular surfaces, slow progress, the marks of 1,000 individual blows. The technique works for removing bulk material. It does not explain the sub-millimeter flat surfaces found on the H-blocks. While abrasion techniques work for sandstone, achieving similar precision on extremely hard andesite remains more mysterious. Bronze tools may have helped, but extensive experimentation is still needed. The mainstream explanation requires additional finishing steps, grinding, polishing, abrasive work after the initial shaping. These techniques also exist. The Egyptians polished granite to a mirror finish using sand, flat stones, and patient labor over years. But the Egyptian examples were reserved for the most sacred objects, the most important tombs. The investment was enormous, and the output was limited. At Puma Punku, the precision is not limited to a few showcase pieces. It appears across hundreds of blocks. Multiple H-shaped blocks show identical precision, as if produced to a specification, checked against a template, and passed only when they met the standard. That is not what hand finishing looks like. Hand finishing produces variation. The hand of the individual craftsman is always visible in the work. At Puma Punku, the hand of the craftsman is invisible. What's visible is standardization, a consistency that suggests not individual effort, but a system, some method of achieving repeatable results across many pieces. What method? That is the question nobody has been able to answer. The H-blocks are the most unsettling artifacts at the site. They are cross-shaped andesite stones with recessed channels and precisely cut notches that allow them to interlock with adjacent blocks. They are cut to such uniform dimensions that they appear mass-produced, a startling quality in a culture without written language or metal harder than bronze. The interlocking geometry is obvious. The blocks were clearly designed to be assembled without mortar, their shapes holding each other in place the way puzzle pieces do. But here is the problem that has persisted for over a century. The blocks do not all fit together. The dimensions vary slightly from piece to piece, as if produced in different batches to slightly different specifications. Despite 120 years of effort, international teams with access to the complete inventory of surviving blocks and modern computer modeling software have never successfully reconstructed what Puma Punku originally looked like. The structure it was supposed to form has never been recovered. There are three possible explanations for this. The structure was so unusual that no recognizable architectural form emerges from the surviving pieces, or a significant number of the original components are missing, or, and this is the possibility that gets discussed quietly at the margins of the field, the blocks were manufactured and transported to the site, and then abandoned before assembly. The Tiwanaku civilization did not end suddenly. It declined gradually over centuries, eventually fragmenting into smaller groups that were later absorbed by the Inca. There is no catastrophe, no sudden collapse. That would obviously explain why a massive construction project was left mid-completion, unless the project was not the Tiwanaku's to finish, unless they found the blocks already there, already cut by someone before them, and were attempting to continue something they did not fully understand. This hypothesis is heretical to mainstream archaeology. It implies a predecessor. It implies knowledge that did not survive its creators. It implies that the Tiwanaku, who were impressive, were building in the shadow of something they could imitate on the surface, but not regenerate from the ground up. Now consider the clamps. One of the 6 major anomalies at Puma Punku is the in situ copper arsenic nickel bronze clamps cast at 3,950 meters elevation in I-beam configurations, integrated with the original block geometry. The builders of Puma Punku used metal clamps to join their stones, T-shaped and I-shaped fasteners poured and molten into channels carved into the tops of the blocks. This technique was also used at Tiwanaku and appears at other Andean sites. It is not unique to Puma Punku. What is unusual is the alloy. The metallic clamps are composed of a complex alloy including arsenic, copper, iron, silicon, and nickel, the latter containing 1.70% nickel, a metal not locally sourced. Getting nickel into the alloy requires either a specific ore source that is not present in the local region, or a level of metallurgical sophistication that goes well beyond what we expect from the Tiwanaku's documented toolkit. Then there are the boreholes. Uniform 4 to 6 millimeter cylindrical boreholes drilled in regular sequences across multiple blocks are one of the 6 independent anomalies that together describe an engineering culture that disappeared without obvious successors. 4 to 6 millimeters, consistent diameter, consistent depth. In andesite, approximately 900 perforations across the site, drilled with a regularity that suggests not individual judgment calls, but a systematic, repeatable process. The mainstream explanation for how these holes were made involves copper or bronze tubes rotated under pressure with abrasive grit. This technique also exists, but the results typically leave marks, slight irregularities in diameter, taper toward the bottom, variations between individual holes. The holes at Puma Punku are cylindrical, not tapered. Their walls are consistent, not irregular. They look drilled in the modern sense, not abraded, which is what led to the geopolymer hypothesis. And this is where the story stops being just about carving and becomes something else entirely. A study published in Ceramics International in 2019 by Joseph Davidovits, Louis Swaman, and Ralph Davidovits analyzed the andesite blocks at Puma Punku using scanning electron microscopy and petrographic evidence. The results showed that the andesite blocks contain organic matter, a finding that is essentially impossible for a naturally formed volcanic rock. Volcanic rock forms at extreme temperature and pressure. It does not contain organic compounds. The presence of organic matter in the andesite indicates, the authors argue, that these blocks are not natural stone at all. They are ancient artificial geopolymer concrete, a material engineered to mimic stone, cast into molds and allowed to harden. If this is correct, it changes the entire question. You do not need to explain how someone cut andesite to sub-millimeter precision with bronze tools. You need to explain how someone made a moldable material that hardened into something chemically indistinguishable from andesite. You need to explain how they cast that material into molds precise enough to produce the flat surfaces and exact geometries we measure today. You need to explain where the organic compounds came from and how they were incorporated. And you need to explain why this technology, which would be remarkable in any era, left no surviving record, no tradition, no continuation. Scientists also found that the red sandstone of Puma Punku cannot come from the local region because it contains elements, including sodium carbonate, not found in the local geology. The largest sandstone blocks at the site, some weighing over 131 tons, appear to be made from material that did not originate anywhere nearby. Either these blocks were transported from a source that has not been identified, which would represent a logistical achievement of extraordinary difficulty, or they were manufactured in place from materials brought in from elsewhere. The transport problem by itself is enough to stop conversation. The nearest confirmed quarry sources for the andesite are approximately 10 kilometers away across terrain that includes ravines and slopes. The red sandstone sources are estimated at 50 to 90 kilometers distant, with some sources placing the Copacabana Peninsula across or around Lake Titicaca as the origin point. The largest red sandstone blocks in the terraced platform weigh an estimated 131 tons. Moving them across or around Lake Titicaca from quarries 90 kilometers distant would have required over 4,000 workers based on standard labor estimates. And that is just to move them, before any cutting or precision work. At 12,800 feet above sea level, where the air contains roughly 40% less oxygen than at sea level, where physical exertion costs significantly more than at sea level, where breathing hard while doing nothing is common for visitors accustomed to lower altitudes, coordinating 4,000 workers to move a 131-ton block across a lake and then up a plateau is a logistical and physiological challenge of a different order than moving the same block at sea level with access to a river. The conventional answer is manpower. Large numbers of people, properly organized, can accomplish remarkable things. The pyramids prove it. But the pyramids were built in Egypt, at sea level beside the Nile, by the wealthiest state in the ancient world, commanding resources from across an entire region. The Tiwanaku were impressive, but not Egypt. Their resource base was smaller, their population was smaller, their environment was dramatically more challenging. And they still had to cut the blocks to tolerances that the best craftsmen working in optimal conditions with the best available hand tools cannot easily reproduce. Radiocarbon dating of multiple construction contexts consistently yields dates between 536 and 600 CE. The occupation of the site and associated ceramics confirm the Tiwanaku period construction. This date is not seriously disputed by mainstream archaeology, so the timeline is clear. The builders were there around 536 AD. What is not clear is how they did what they did, and the 3D scanning program now quantifies exactly how unclear the answer is. Submillimeter joint tolerances on andesite were confirmed by a 2018 3D printed reconstruction by Alexey Vranich, published in Heritage Science, assembled from over a century of compiled field measurements. The project printed 140 andesite pieces and 17 sandstone slabs and physically reassembled the building on a tabletop. The results confirm a level of fit that pre-Columbian Andean masonry was not supposed to reach. Think about what that reconstruction project actually did. Over a century of field measurements, from the first European surveys in the 1890s through to modern work, were compiled and used to generate 3D printed scale models of 157 surviving blocks. The team then tried to physically fit those pieces together. Some did, some didn't, but the measurements of the individual pieces, the flatness of their faces, the angles of their corners, the depths of their grooves, confirmed what researchers had been saying for decades. The precision is real. It is not a matter of perspective or lighting or selective observation. When you put the numbers into a computer and the computer prints the pieces and you try to assemble them, the precision holds in the physical world the same way it holds in the measurements. Toolmark examinations reveal repetitive abrasion patterns instead of single decisive cuts. This supports a model of gradual shaping using stone and copper-based tools, consistent with known pre-Inca architectural techniques. Experimental reconstructions suggest that such precision would have required standardized measurement systems and careful planning, pointing to organizational sophistication rather than unexplained or lost technologies. This is the mainstream position, and it deserves to be stated plainly. Mainstream archaeology does not think Pumapunku requires an unknown civilization, lost technology, or anything supernatural to explain. It requires skilled workers, good organizational systems, standardized measurement, and an enormous investment of time and labor. The Tiwanaku were capable of that. Other civilizations at comparable development levels achieved comparable or greater things. What mainstream archaeology has not yet done is demonstrate, in experiment and replication and practice, how you get from copper tools and pounding stones to surfaces flat to 0.05 millimeters on andesite. The theoretical explanation exists. The practical demonstration does not. Nobody has gone to Puma Punku or a comparable site with documented period-appropriate tools and produced a surface to that specification by hand. The experiment has not been run, which means the gap between the explanation and the evidence has not been closed. It has only been described. How were the andesite blocks precisely finished? While abrasion techniques work for sandstone, achieving similar precision on extremely hard andesite remains more mysterious. How were templates and measurements standardized? The modular design implies sophisticated planning, but no templates or plans have been found. No templates, no plans, no instruction manuals, no tradition that survived. By the time the Inca arrived and absorbed the remnants of what the Tiwanaku had become, they did not know who had built the monuments on the Altiplano. They attributed the work to the gods. The Spanish conquistadors who saw the site in the 16th century described it as wondrous and unfinished. And then they used the blocks as building material. They built church foundations with H-blocks. Railroad construction in the 19th century removed more. Centuries of earthquakes scattered the rest. What we are studying today is a debris field, a ruin of a ruin, a puzzle with an unknown number of missing pieces, a record of something whose complete form we have never been able to recover. Even so, even in this fragmentary state, what remains is extraordinary enough to keep stopping engineers, archaeologists, and material scientists in their tracks. The flat faces, the internal corners, the standardized grooves, the boreholes, the clamp chemistry, the organic matter in the andesite. Individually, each of these is a puzzle. Together, they describe something that does not fit comfortably inside any framework archaeology currently has available. 6 rigorous anomalies, submillimeter H-block tolerances, peer-reviewed geopolymer evidence, cylindrical boreholes, in-situ copper-bronze clamp casting, 100-ton block transport from Copacabana quarries, and the persistence of alternative dating, despite radiocarbon contradiction, together describe an engineering culture that disappeared without obvious successors. What makes Pumapunku genuinely hard to explain is not the scale, but the precision held across that scale, on stone with a Mohs hardness of around 6, using a documented Bronze Age toolkit. That last line is the honest summary of where things stand. The labor scale, difficult as it is theoretically achievable. What has not been explained is how precision at this level was maintained across that labor scale, in this material, with these tools. The history of archaeology is a history of underestimating ancient people. The Maya were thought incapable of the complexity their cities reveal, until LiDAR stripped the jungle away and showed cities larger than anyone had modeled. The Antikythera mechanism was pulled from a shipwreck and dismissed as impossible until its gears were analyzed, and it turned out to be a mechanical astronomical computer of extraordinary sophistication, built 2,000 years ago. The Egyptians' stonework tolerances in the Great Pyramid keep astonishing engineers who measure them for the first time. At every step, ancient peoples turn out to have been more capable than the consensus assumed. Pumapunku may be the next step in that process. Not proof of anything supernatural, not evidence of visitors from elsewhere. Proof of human capability that has been systematically underestimated. Capability that emerged at 12,800 feet above sea level, in the thinnest air on the inhabited planet, from a civilization that left no written record, no surviving technical tradition, and no explanation. The Tiwanaku, or whoever preceded them, looked up at the Andean sky from that windswept plateau. They cut stone, or cast stone if the geopolymer hypothesis holds, to specifications that modern industry recognizes as precision work. They assembled a structure that Spanish conquistadors described as wondrous and unfinished in the same breath. And then the knowledge was gone. The Inca who came after did not have it. The Spanish who came after the Inca did not find it. The archaeologists who have been walking this site for 120 years have not recovered it. The 3D scans made the precision impossible to deny and impossible to explain away. The geopolymer study opened a line of inquiry that could reframe not just how the blocks were shaped, but what they fundamentally are. The borehole analysis raises questions that standard tool use models cannot cleanly answer. The clamp chemistry points toward metallurgical knowledge beyond the expected toolkit. None of this has a settled answer. The blocks are what they are. The measurements are what they are. The stones do not explain themselves, and the people who made them left no record of how. Just the work itself, precise, anomalous, silent, scattered across a plateau in the Bolivian highlands, asking questions that 120 years of archaeology has not been able to answer. The measurements are in. The mystery remains. And every new instrument pointed at these blocks adds resolution to the problem without yet providing the solution.